What's up, guys? This is Mr. O'Brien. This series of lectures is going to be regarding formation of covalent bonds, but this is part 2 on the lecture series. And we're going to be talking about molecular shapes. This information can be found in section 9.4 of your text. And before we start out, it's really important that you know electron dot structures, especially in regards to creating covalent bonds. So if you don't know this, go back to the part 1 series of covalent bonds and review that because you're going to need to know that for this information. So in class, I gave you a chance to take a look at a little activity in which you have kind of played around with atoms to observe the different shapes, molecular shapes that they can create based on this theory of VSEPR. It's the valence shell electron repulsion idea. Now, what it's all about essentially is we're looking at atoms and how they repel against other atoms. And remember, it's the electron clouds of these atoms that repel. And so we're looking at how they are placed around a center atom to maximize the space to minimize that amount of repulsion that's occurring. So there's a couple ideas that you had to recognize when you had a chance to play around with this before we even looked at it in class, right? So let's get started. How do we identify the shapes based on the Lewis structures, or as we call them, the electron dot structures, right? So there's a couple of factors. One factor is that you got to know how many atoms are bonded to the central atom, right? So if you have 2 atoms that are bonded to it, you might have a linear. If you have 3 bonded atoms to a center atom, you might have a trigonal. Or if you have 4 bonded atoms to a center atom, you might have a tetrahedral. Now, there's another factor in all this, right? How many lone pairs are on that center atom? Because what we're focused on is the bonded atoms' shapes, right? So that will be affected by the lone pairs. The lone pairs essentially act like bonded atoms in which they have electrons that push and repel against the electron clouds of other atoms. And so how many lone pairs you have really dictates the shape of what your molecule is going to be and the bonded angles that occur. So these are the 5 basic shapes that you got to recognize in this class. And there's way more, and your textbook may have a lot more. But these are the basic shapes that you got to recognize. And let's go look at these in more closer detail. Okay? So the first shape, linear. So linear looks like this. You have 2 bonded atoms at 180 degrees apart from each other. There are no lone pairs on that center atom. So if you take a look at carbon dioxide, here's the electron dot structure for carbon dioxide. You have 2 bonded atoms, and there is no lone pairs on the center atom. Because of that, you have an 180 degree bond angles. The electron cloud of this atom has maximum amount of space to minimize that repulsion with the other electron clouds present. And this linear shape also applies to the simple 2 atom connections like oxygen gas or nitrogen gas. And the cool thing is here, you can actually see the bond length actually is shorter, and even in the model, right, in this triple bond, as in this double bond, it's a little bit longer. An idea that we learned about in part 1. All right, let's talk about the trigonal planar. So in trigonal planar, you have 3 connected atoms, hence the word trigonal, right, on the center atom, and there is no lone pairs. Now, yeah, there's going to be like an exception to a rule, like boron, that kind of makes these shapes, but there are other atoms like carbon that can also create shapes like this as well. Now, what does a trigonal planar look like? Now, notice that there is no lone pairs on that center atom pushing or affecting these bonded atoms together. So they kind of sit like a flat paper. As you can see here, here's a side view, and here's the top view, right? They're really far apart from each other, right? They minimize that repulsion from each other, right? And the side view has them flat, hence the word planar. Planar means flat. Now again, we don't really care about the number of bonds that are connected, or single or double or even triple, because you're still going to have the same shape, right? So it's the amount of atoms connected and the lone pairs. Okay, So here's a tetrahedral. Tetrahedral has 4 connected atoms to it and no lone pairs on a tetraatom. And the word tetra really is 4. That's what it means. It's like the prefix for 4. So here's a tetrahedral structure. Notice that the number of atoms, these 4 bonded atoms, are placed in certain distances away from each other. That minimizes that repulsion. It's almost like a pyramid in which where that like center atom is in the dead center of that pyramid. And again, it won't matter the number of bonds. You can have a single here, or a double, or triple. You're still going to have the same shape. Okay. All right. And the other one is called the trigonal pyramidal. Now, trigonal pyramidal has 3 connected atoms, hence the word trigonal. But it's got 1 lone pair. So that the 1 lone pair essentially pushes down on a trigonal planar atom, right? And it pushes those guys downwards to make it essentially stand up. Well, let's take a look and we'll see what it looks like. So here's your trigonal planar. Well, when I add a lone pair to it, notice how the atoms are essentially pushed down, the bonded atoms. It almost looks like a tetrahedral in a way, right? If you kind of consider. And here you have like the side view model for this tetrahedral, for this trigonal pyramidal shape. Again, it's a confusing model to some students because it looks like trigonal planar because you have 3 bonded atoms. But again, that lone pair, which you see right here, really pushes down on those bonded atoms, right? And makes it essentially stand up. Now the pyramid, the center atom is at the top of that pyramid. Okay, and then our last shape here is regarding a bent shape. In the bent shape, you have 2 connected atoms on a center, 2 connected atoms on that center atom, and then you could have 1 or 2 lone pairs. So consider this example for water, right? So in water, you have a you have 2 atoms hooked up together with 2 lone pairs. Now notice that the lone pair pushes down on them, but a second lone pair even shrinks that bond angle even much more, as you can notice in a second, from 120 to now 109, right? And you can see here an example of a 1 lone pair or 2 lone pairs. You're still going to have that bent shape to it. And again, it doesn't matter if you have a single bond or a double bond or a triple bond connected here. It's the number of atoms and the lone pairs that we're looking at. Okay. So here's a cheat sheet, right, taken from your book of the 5 basic structures that you're going to need to know. You can print those out and keep them in your notebook, but ultimately you're going to have to know them. So practice this idea of identifying the molecular shapes, and then if you have a hard time with this, hit me up at tutorial. Thanks.